Hi there, and welcome back to our Grade 12 Geography Cap series. I'd like to thank you for tuning in, and I hope this video will be of benefit to you. Now, for those of you who are new to this channel, I'd like to welcome you. I'm Andrew Commander, and I do make YouTube videos on the CAPS curriculum. So, in the previous video, we went through the mid-latitude cyclones. Okay, so if you haven't checked that video out, guys, please do. It should be in the same playlist as this one. Okay, so it should be the second and third video. So what we did, we broke down the mid latitude cyclones into two videos. Okay, so we made a video that covers these concepts, the general characteristics of mid latitude cyclones, areas where mid latitude cyclones form, conditions necessary for their formation, and lastly, the stages of development and related weather conditions. Okay, so if you search that up, it's actually written mid latitude cyclones, stages of development. Okay, so that video actually entails all of these concepts, okay, under mid-latitude cyclones, okay. And then part two of mid-latitude cyclones includes the occluded fronts, okay. So we went through and discussed the different types of occlusion fronts and their related weather patterns, and we also discussed the impact that mid-latitude cyclones have, as well as the strategies that we can implement to manage the impact. Okay, so that is written occlusion fronts. Okay, the video, it's also under the mid-latitude cyclones. Okay, so you'll find both of these videos in this playlist, okay, which is the Geography Caps series. Okay, now for this video, we are looking at tropical cyclones, and we'll also break this down into two separate videos. One video, which is this video, will cover general characteristics, areas where tropical cyclones form, factors necessary for their formation, and the stages of development. Okay, so these are the four concepts that we shall cover in this video. Okay, the following video will include, of course, the impact that tropical cyclones have, and how you identify them in satellite images and in synoptic weather maps. Okay, now, first of all, guys, both of these are cyclones. Okay, so both of these are cyclones, and we actually discussed what cyclones are. We said that cyclones are actually associated with a low pressure. Okay, that's actually associated with rising warm air. Okay, which results or creates an area of low pressure at the surface. Okay, so this area of low pressure promotes surface convergence. Okay, so more air is actually invited or drawn in towards the center of this low pressure and actually converges here. Okay, so that's what we call the surface convergence. It rises up. As it is rising up, it actually cools down. Okay, so it's actually cooling down as it is rising up and actually condensing into from gas into liquid. Okay, so now you start seeing cloud formation, and hence is also associated with precipitation. So that is what a cyclone is. We also discussed upper divergence of air. So this should be in the very first video, guys. We discussed all of these concepts, the upper divergence of air. Okay, so this type of circulation is what we see in both cyclones. Okay, and we also said that cyclones actually rotate clockwise in the southern hemisphere, both of them. Okay, in the southern hemisphere, we see a clockwise rotation like that. Right. Okay. So, and then for the mid latitude cyclone, we said that they are mid latitude. This word in this term actually refers to the area in which they develop, which are the mid latitudes, which is of course between 40 and 60, right, degrees north or south of the equator. And now for the tropical cyclone, the tropic part actually refers to the region in which these cyclones develop, okay, which is actually between 5 and 25 degrees. Okay, right, so let's get into it now. Okay, so a tropical cyclone essentially is a low pressure system which develops over warm oceans. Okay, we will discuss why. and affects regions between 5 and 25 degrees north or south of the equator. Okay, so as you can see, guys, this is again specific. Okay, why does it develop in this particular region, and why does it develop over warm oceans? Okay, why not over land? Why over oceans, and why do they have to be warm? So all of those questions will be answered in this video. So stay tuned and enjoy it. Okay, so let's start with the area of development of tropical cyclones. So in the definition, we said that these actually develop between 5 and 25 degrees north or south of the equator. Okay, so some of you may ask, why not between 0 and 5? Why don't these develop between 0 and 5? Why do they start at 5 degrees all the way to 25? Okay, and why not between 25 and 30? Why this particular region? Okay, so if I would point out this region here, okay, in our model. Okay, so between 5 and 25 should be somewhere. So that should be 5 and that should be 25. Okay, so we're saying that we see tropical cyclones developing only in these regions and on oceans. They develop over oceans, right? So it must be the northern hemisphere and also the southern hemisphere. Okay, the first question is why? Why do we have them developing between these regions? Okay, in these regions, I mean. Right, so the first answer to that, so why aren't they developing between 0 and 5 degrees? Okay, so the answer comes to Coriolis force, right? So remember Coriolis force, we said that this is a force that's actually responsible for spiraling of winds, okay? So you'd find that when you have an area of low pressure and of course you have relatively um, air molecules or air masses from relatively higher pressures, okay, will move towards this low pressure, okay. And so what happens now? They do not pass through each other, but they actually collide and start to rise up, okay. So as they are rising up, guys, they are not rising up just vertically like that, okay. So as they are also as they are while they as they are moving towards each other, they get deflected. Okay, so by deflected we mean that they change direction. So if you have an MS moving in that direction, the Coriolis force in the southern hemisphere will deflect it like that. Okay, so as you can imagine this, so this MS will be deflected that way, this will be deflected that way, this will be deflected that way, and that will be deflected that way. Okay, so as you can see from a top perspective of it or a top view, what you will see is this clockwise circulation. So as they are moving towards this low pressure, they actually get deflected, okay, such that they rotate clockwise. So as they are rising up, okay, they are rising up while rotating, okay, while rotating, right? So that's what we actually see there, okay? They are rising up and they are rotating while doing so, okay? And so this is caused by Coriolis force. And this actually leads to further development of a tropical cyclone, okay? Because as they are actually rotating, more air gets drawn in from other areas and actually joins this and actually results in a much bigger, much more developed tropical cyclone. So it is critical for the development of a tropical cyclone. There has to be strong Coriolis force, guys. Okay? That is a requirement, right? Now, with Coriolis force differs. The value of Coriolis force or the strength of Coriolis force actually differs from region to region, right? So we say that as you move towards the poles, okay, so meaning which as you increase, as you go up in latitude, meaning which from 0 going towards 90 in the northern hemisphere, 0 going towards 90 in the southern hemisphere. So as I'm moving towards the poles, the Coriolis force increases. Okay, so we say Coriolis force strength increases towards the poles. So one would assume, of course, or would say, deduce that the Coriolis force is the strongest at the poles. Okay, so if it is the strongest at the poles, then it must be the weakest at the equator, right? So that definitely goes straight to answer your question. So the reason why tropical cyclones do not develop between 0 and 5 is because the Coriolis force is too weak, okay, to promote the spiraling of air. Okay, there is too weak to promote the spiraling of air and hence the development of a tropical cyclone. If we would form, it would not further develop. Okay, or it would not develop to a stronger um, to a stronger stage or a mature stage because it needs this Coriolis force for it to spiral, for it to further grow and develop. Okay, so that's our answer there. Why don't you get tropical cyclones developing between 0 and 5? Well, a tropical cyclone requires Coriolis force. Okay? And between 0 and 5, the Coriolis force is actually very weak. Okay? So Coriolis force, remember, is responsible for the spiraling of wind. That's what we call the vortex. So vortex is that movement that you see, the spiraling of wind. Okay, there we go. So the spiraling of wind is what we call the vortex. So at this region, it is the weakest in strength, and hence it cannot promote the development of a tropical cyclone. Okay, and then why? And you would ask why not between 25 and 30? Well, between 25 and 30, okay. Actually, let me start by saying the tropical cyclone actually requires a constant feed of or supply of warm air. Okay, because warm air is light. Okay, and it has a high moisture. It has a lot of moisture. Okay, so this enables it. Okay, because it is light, it enables it to rise up. Because it has a high moisture, it enables it to form clouds. Okay, so you have to think of this like your kettle at home. So when you switch on your kettle, what actually happens is that the water inside actually warms up. Okay, so as it warms up, it evaporates. So when it is about to boil, it evaporates. You start seeing, okay, vapors, okay, of or gases that actually come out like that. So that is warm, moist air coming out. Okay, and if you actually have, let's say, you have a surface above this kettle, you will find that as soon as this warm, moist air hit the surface, they actually turn into water particles. Okay, so they form these water droplets there. That is condensation, guys. This was gas, now it's actually liquid. Okay, right. So it's very necessary that it is moist. So your air, your warm air that you're talking about has to be moist because with being moist, it's able to change phase from being gas to being liquid. Okay, you can have warm, dry air, but if it is dry, it cannot promote condensation and hence no precipitation. Okay, it can rise up, but because it is dry, it has no water vapor, it cannot result in precipitation, rainfall forming. Okay, right. So we are saying that tropical cyclone's second requirement is that it actually needs a constant feed or supply of warm air, right? So you have to have a warm ocean where you're going to get warm, moist air. Well, you're going to get warm, moist air from the warm ocean. Okay, so you have to have a warm ocean. Warm ocean will feed that tropical cyclone with warm air. Okay, because it is evaporating. As it is evaporating, that gas actually feeds into the developing tropical cyclone. So now the reason why it's not developing between 25 and 30 is because between 25 and 30 degrees north or south of the equator, the oceans are relatively cold. Okay. And so there's no longer that supply of warm, moist air, and hence no more fuel added to the tropical cyclone, and hence this does not promote development or growth. Okay, and also we know that cold air tends to sink down. Okay, because cold air tends to sink down, increases the pressure. Remember, as the as the warm air, as more warm air rises up, guys, the pressure becomes lower and lower and lower and lower. It becomes strong, and so the system becomes stronger and stronger and stronger. But once you have cold air entering the system, now you are increasing the pressure, and hence now the pressure, and hence now the tropical cyclone is actually weakening. Okay, so this disrupts the rotational movement of warm air, because instead of rising up, it actually sinks down. And instead of decreasing the pressure, it's actually increasing the pressure. Okay, so that's why tropical cyclones cannot develop in these regions, because these regions do not have that supply of warm, moist air needed for the tropical cyclone to further develop. Okay, right? So that is very important, guys. Know the reason why it does not develop between 0 and 5 and between 25 and 30. Okay, these are two different types of regions, and it is linked, and they are both linked to the requirements of a tropical cyclone. Okay, so if a requirement is not met in a tropical cyclone, then it cannot further develop, right? Okay, so we call it a tropical cyclone here in Africa. What about other regions? Because it does not have only one name. Well, in North America, they call it the hurricane. Okay, they call it the hurricane, and in Asia, they call it the typhoon. Of course, in Africa, they call it the tropical cyclone, and in Australia, they call it the willy willies. Okay, so these are the names that you should also remember. These would be maybe few. These would maybe count for a few marks, but again, guys, we have to collect every single mark that we can get. Okay, so before we head on to the necessary conditions, let's talk about the condensation. So what happens? So we're saying that these tropical cyclones develop over warm oceans. Why? Because warm oceans have high evaporation. Okay, if they have high evaporation, that means they produce a lot of warm air, warm moist air, I mean. And so warm moist air, what does it do? It rises up. And so now that you have warm air rising up, you develop an area of low pressure at the surface. Okay, we talked about these guys in the first video. I will not go through that again. Please watch that. So now that you've created an area of low pressure, air from relatively higher pressure areas is invited or is drawn towards this very low pressure. And hence now we see surface convergence. And so air now starts to, more air or more air masses start to increase. There's more volume of air that is rising up. Rising up. So now you have more air rising up and cooling down, okay, in the upper atmosphere. And hence, by cooling down, guys, we're actually transferring energy from the lower altitudes to the higher altitudes. Okay. And so now this energy is used or is actually released. Okay. So what happens now is this warm, moist air cools down and condenses. So during the condensation, okay, so condensation again, this is a phase change, okay, from gas to liquid, for us, I'm going to say from air to water, right? Okay, so that is condensation. Remember, clouds are made up of water particles. Okay, so we actually um, um, changing phases from air to water. Now, as this phase change occurs, there's an energy that is being released. Okay, so these plus signs here, I guess, illustrate the energy that is being released as condensation occurs. So this energy that is being released as we change phase from air to water, that's what we call the latent heat. Okay, so you say latent heat is released as warm air condenses. So latent heat, guys, this basically adds more fuel or basically promotes further development of the tropical cyclones because this latent heat actually provides this energy to the surrounding water particles, I mean air particles, which get energized and enter the system again and join the circulation again. Okay, and so this continues further on. Okay, so as you can see, there's going to be even more MSs that join the circulation. Okay, because latent heat is released and it feeds into the system or adds fuel into the system, leading to further development of the tropical cyclone. Okay, so it's very important that you know that latent heat is released during condensation and it participates in pro- in developing the tropical cyclone even further. Okay, right. Now, let's look at the conditions that are necessary for formation. Okay, so what do you need in order for you to have a tropical cyclone developing? Okay, what is necessary for its growth? Okay, first of all, for its formation, because it has to first grow, it has to first form, and then rise, and then grow. Okay, so it first forms and then grows. So for it to form, first of all, there must be an ocean that is warm. Okay, because an ocean that is warm provides warm, moist air, and warm, moist air rises up, creating a low pressure. Okay, so you can imagine there you have an ocean, and this ocean has a temperature that is warmer than 26.5 degrees Celsius. Now, the textbooks have different values. Just confirm to your teacher which temperature that you are required to know. But I really believe that it is 26.5 degrees Celsius. Some say it's 27, so on and so on. Okay, so the ocean must be warm, guys, right? Because this promotes, because it will evaporate. Okay, again, go back to that kettle of yours. You have water inside. Okay, in order to form this warm, moist air, you have to boil, you have to switch that kettle on such that water boils and evaporates into air particles, into this warm, moist air. The same thing applies here. Okay, you have to have warm ocean that will have high evaporation that will produce warm, moist air. Warm, moist air that will rise up, okay, okay, because it is, and because it is applying little pressure on the surface, an area of low pressure is created on the surface. Okay, so this is the first thing that must happen. Okay, you must have a warm ocean, okay, warmer than 26.5 degrees Celsius. Okay, because it supplies warm, moist air, okay, and forms an area of low pressure eventually. Okay, that's what we need. That's the first step. Now, the second step, there must be surface air convergence. Now, how is that going to happen? Well, now that you have an area of low pressure, air from the surrounding regions will be drawn towards that low pressure. Okay, remember, air always moves from an area of high pressure towards an area of low pressure. So areas that have relatively higher pressures will have their MSs moving towards this low. this low pressure there at the center. And so when they move towards each other, they are not going to pass through each other, but they are going to meet up. They are going to converge. That's what we call the surface convergence. They are meeting up at the surface. Okay, this is critical because this results in them meeting up, colliding with each other, and then rising up. Okay, that's what we need. We need them to rise up. We need air to rise up, but it has to first collide. Okay, so as you can see, this means that um, more air masses from different areas, from different places, actually are drawn towards this low pressure. So this will promote further growth, and hence we need surface air convergence. Okay. Now, in order for these to continue on, we need, okay, remember this warm air, as it rises up, it will cool down. And as it cools down, it will condense, form clouds. But eventually, it will separate at the top. Okay. And we call that upper divergence. Okay. So it separates. Now you have cold air. This is now cold air. It will then sink down at some point. So as it sinks down, okay, now it will warm up. Okay, so as it moves down, it actually warms up, and guess what? It will again move towards that low pressure. Okay, so as you can see now, you've created this circulation. Okay, this circulation will is actually maintains the growth of the tropical cyclones. Okay, so it actually sustains the tropical cyclone. Okay, so that it keeps on growing and not dissipate. Right. Okay, so that's what we need. We need upper divergence to um, conserve this circulation, to conserve this growth. Okay, right. So another condition is that, of course, it must develop over the ocean, guys. It cannot develop over the land because the land is dry. Okay, land it does not have a lot of water surfaces because the highest moisture you can get, guys, the highest moisture you will get is in the ocean. Land is very dry. Okay, you have soil. Soil is dry, does not have a lot of water content, and hence, remember, it said that the tropical cyclone needs a constant supply of moist air, and that moist air you will only find it in the ocean because the land is dry. You cannot have a constant supply of warm air. And because the land actually has many barriers, buildings, bridges, everything, it's just um, on it's just standing in the way of a developing tropical cyclone. So if it's going to develop, okay, it's going to collide with these buildings, it's going to slow down, it's going to die off. Okay, and so that's why a tropical cyclone needs to occur over the ocean. Right, and it must be a warm ocean. Right, okay. We need a Coriolis force, okay, in order to promote the vortex. Okay, the vortex we said again is the spiraling of winds, okay, responsible for the growth of the tropical cyclones. Okay, has to keep on spiraling. Right. Uh, there also should be a supply of moist air. So we've already covered these two. Right, so those are some of the conditions that are necessary for the formation and development of a tropical cyclones. Okay, you're gonna get this wrong, guys. If you get this in your exam or in your test, there are many conditions necessary for the formation. You cannot get it wrong. Okay, now let's go ahead and look at the characteristics of tropical cyclones. Okay, what else do we need to know about tropical cyclones? Well, tropical cyclones we use the we use alphabetic names. Okay, we name them, give them names. So they receive alphabetic names according to the sequence of occurrence. Okay, so what do we mean by that? Well, if I have tropical cyclone Amanda and tropical cyclone Buhle and tropical cyclone, let's say Kristen, Okay. Which tropical cyclone occurred first? Okay, so that's the usual question. Well, you go with, you look at the first letters of these words, okay, of these terms. In this case, A comes first in the alphabet. And so this means for us that A should be the first tropical cyclone that had occurred in that particular season. So this must have been the first one, and this must have been the second one, following Tropical Cyclone Amanda. And Tropical Cyclone Christine must have been the third one. Okay, so you look at the alphabets of the alphabet, particularly the first letter of the name. Okay, you don't have to know you don't have to use all of these letters in that name. Look at the first letter of that particular name, and um, and that will tell you when it occurred relative to um, um, other tropical cyclones. Okay, so please be aware of these, guys. You cannot get these questions wrong. These are free marks. Okay, right. Say that tropical cyclones develop in late summers and early autumns. Okay, why don't they develop in early summers? Why late summers? Okay, well, the reason, guys, is because the ocean has a high heat capacity. So, a high heat capacity basically means that the ocean takes much longer for it to heat up. Okay, so it will take much more heat for it to move from 1 degrees Celsius to 2 degrees Celsius. It needs more heat compared to land. Land has a lower heat capacity. Land warms up very quickly compared to the ocean. So for the ocean, it takes much longer. So as you can imagine, if this is a period of the summer, okay, so let's say this is December and this is March, okay, the right hand side. So a tropical cyclone will develop only during this time, okay, during towards March, okay, because well the ocean is warming up during this time, okay. It is actually warming up, warming up, warming up until it reaches that 26.5 degrees Celsius. Now you start having tropical cyclones developing. Okay, so can be late summers or it can be early autumns. Remember, the season that follows summers is autumn. Okay, so it can spill into that, so it can develop in early autumn as well. Okay, so that's why if they ask you that question, it actually because the ocean has high heat capacity, it takes longer actually to heat uh, or to reach that 26.5 degrees Celsius, right? Okay. The third characteristic is that tropical cyclones, unlike mid-latitude cyclones, they move in the opposite direction. They move from west to east. Remember, we said mid-latitude cyclones move from east to west. I mean, this is a mistake. Okay, so this should have been. Oh, yeah, this is actually correct, right? No, it's actually a mistake. So this should have been. They move from. Okay, let me do this. Okay, so tropical cyclones move from east to west, guys. Okay, east to west. Sorry about that. Okay, remember, mid-latitude cyclones move from um, west to east, and tropical cyclones move from east to west. Okay, and the answer again lies in major winds. Okay, remember we said that mid-latitude cyclones, the reason why they move from west to east is because, well, during their mature stage, they move into this region and they get pushed. Like, can maybe imagine someone, okay, let's say I'll try to draw someone's mouth here, okay? Like, So like you can think of like someone blowing them towards the east. Okay, and these that someone is actually these subtropical westerlies that are moving towards the east. As you can see, these westerlies, okay, moving towards the east, and that's how we reasoned as to why mid-latitude cyclones move from west to east. And tropical cyclones actually move the opposite direction. They move from east to west. Okay, the reason why, you can guess it. Come on. As you can see, they are in the they are in the tropical easterly belt, wind belt. Okay, so as you can see, you have winds that are moving towards the west. Okay, which are what we call the tropical easterlies. So the tropical easterlies actually drive tropical cyclones and they push them. Okay, so now the mouth is pointing in this direction. Okay, I don't know. I'm a terrible. Wow. Okay. Yeah, you guys will forgive me. Okay, let's say this is a mouth. So you are blowing towards the west, right? So now, if a tropical cyclone is right over here, it will move towards the west. Okay, so that's why it's moved towards the west because it is driven by easterlies. Don't try to explain a lot, guys. Just say that it moves towards the west, or it moves from east to west because it is driven by tropical easterlies. Okay, for the mid latitude cyclones, it moves from west to east because it is driven by subtropical westerlies. Okay, that's it. You've explained it. Nothing more to explain. Okay. Um, a tropical cyclone is what we also call an intense low pressure system. Okay, it's intense because the pressure at the center is lower than 1,000 hectopascals. Okay, that's why we call it intense. Okay, remember mid latitude cyclones have an average pressure that is above 1,000 hectopascals. Okay, and having this intense low pressure actually means or implies that these cyclones actually invite more air at a higher speed, at a very high wind speed. They invite or draw in more air from surrounding regions at high speeds to move to that low pressure. Also related to steep pressure gradient. We'll talk about that now. So say that it's an intense low pressure system because the air pressure is below 1,000 hectopascals. And what we mean by that is that there's a lot more, or there's a lot more air that is rising up, and hence leaving an area of low pressure, of a very low pressure at the surface. Okay, right. Um, because this is a cyclone, there's clockwise movement of air. Again, guys, it's a cyclone. Doesn't matter whether it's mid latitude or tropical. If it's a cyclone, you'll have clockwise movement of air in the southern hemisphere. That's it. Closed case. Case closed. And then it's also associated with a steep pressure gradient. Okay, so we mean that these winds. Okay, so you have winds that are actually being invited towards or drawn in towards this low pressure at a high speed. Okay, and they are moving rapidly, rising up rapidly. Okay, this of course results in tall cumulonimbus clouds. They are able to build tall cumulonimbus clouds because there's a huge warm MS or MSs that are being drawn towards this low pressure at very high speeds. So as you can see, they can reach up to 3,000 kilometers per hour. That is very, very high wind speeds. Okay, so that is what we mean by a steep pressure gradient. Okay, we have a region in the tropical cyclone that we call the eye. So it's basically a part of a tropical cyclone in which you get calm air. Okay, it's actually the opposite of what you would associate a tropical cyclone with. Okay, because when we think of a tropical cyclone, we really think aggressive, okay, violent, destructive. But this part of the tropical cyclone is the calm region of it. Okay, so you find that If I'm looking at the top, okay, of a tropical cyclone, okay, the top view, so you'll have winds that are spiraling like that. Okay, actually should be the other way around, like clockwise. Okay, remember we are in the southern hemisphere, so I also always have to use clockwise. So you'll have this band of winds and this band of clouds, okay, and they are moving clockwise. And then right at the center, guys, right at the center, you have this region, okay, right over here, okay. So as you can see, this region right here is what we call the eye. So the eye is calm cause actually has instead of rising air, it actually has descending air, okay, or sinking air. So as we know, as air sinks down, guys, it warms up. So this air warms up, and if you were to stand at the surface like that, you will actually experience warm air, okay, because the cold air from the upper atmosphere sinks down and it warms up, and we say that it warms up adiabatically. We say that this is adiabatic warming, okay. This is increase in temperature with decreasing altitude or height, okay. So this would be your eye, and then right next to the eye you have high cumulonimbus clouds, okay, surrounding it. As you can see, um, these are supposed to illustrate clouds, okay. So if I would draw this from a side view, okay, so this would be the clouds, okay, there you go, these are clouds, high cumulonimbus clouds, and of course it is pouring with rain, okay. The eye is what um, is referred to when you hear the phrase "the calm before the storm." Okay, so it's actually calm. There's no clouds here in the eye. It's the wind speed is calm, and it's warm. It's actually very warm here. But once you move from the eye, moving towards the eye walls, then you get a problem because now you start experiencing this very aggressive weather. Okay. By the way, we'll talk about this, the cross section of a tropical cyclone in the next video, right? So once it reaches the land, because um, during as it is developing, it's actually moving on the ocean, okay, over the ocean. But once it reaches the land, okay, it dies out, okay. So because the land actually does not have that constant supply of moist air that the ocean has, okay, so there's no more fuel that is being added to further develop the tropical cyclone. And also because there's a lot of barriers there, a lot of buildings, and so the tropical cyclone is slowed down as it is moving on land, over the land. Okay, so when it reaches the land, that's where it reaches decaying stage or the last stage or the dissipating stage. Okay, talking about stages, let's discuss the stages of development, guys. Okay, so similar to the mid-latitude cyclone, we have four stages of development here as well, right? So we have the initial stage, the development stage, the mature stage, and the decaying stage, right? And like the mid-latitude cyclone stages of development, you have to um, remember all these stages. Again, guys, you don't have to remember everything. Just uh, just use one clue, one or two clues to identify a stage. Okay, because they can just provide you with a drawing and they say identify the stage, and then they ask you explain your answer. Why would you say this is an initial stage? Why would you say this is a development stage? Okay, so you just need to remember the very important events in each of these stages. Okay, so let's start with the initial stage. Okay, now say that the tropical cyclone occurs over the ocean, right? So the ocean has to be warm first of all, right? We said that's the first thing. Okay, it must be warmer than 26.5 degrees Celsius. Okay, and so if it is warm, then this means that evaporation will occur. Okay, if evaporation occurs, that means that we are going to have warm, moist air. Okay, so we'll have warm, moist air, and warm, moist air tends to do what? Tends to rise up. So now we'll have warm, moist air rising up. Now, once you have warm, moist air rising up, you start creating an area of low pressure. Okay, before I do that, this warm, moist air is not rising up in this vertical linear manner, but rising up in a spirally manner. Okay, but now this spiral is not strong yet. Okay, I mean the wind speeds are not very high, so it's just um, spiraling, but at relatively lower wind speeds. Okay, so it's rising up. While it is rising up, it is rotating or spiraling. Okay, and so of course, as you have warm air rising up, how much pressure are you exerting on the ground? There's low pressure. There's low force that you are exerting towards the ground. Okay, and so now you have created an area of low pressure. More air from relatively higher pressures is thrown towards this newly developed low pressure. Okay, now you start having what? Surface convergence. Okay, so we see convergence of air towards the low pressure. I mean, so far there's not a huge amount, a huge volume of air that is rising up, and hence the pressure is still not low. Okay, remember, the more you have warm air rising up, higher the volume of warm air rising up at a higher speed, the air pressure will drop. Okay, now but now in the initial stages, you can see the pressure is above 1,000. Right, so a vortex is created. Okay, so as this warm air converges at the surface at the center, it rises up and spirals. Okay, and the wind speed is actually increasing. Okay, so it can go up to 60 kilometers per hour. So it's not as high. Okay, but it is going to develop further on. So this is what you look at. Look at the pressure. That's the initial stage. Look at the pressure there. You still do not have the eye developed. So the eye hasn't yet developed in the initial stage. Right. Right. And then in the next stage now, which is the development stage, what do we see? Okay. First thing, guys, we see that we have an eye developing. Okay. The eye is present but not yet fully developed. Okay. And more warm air actually rises up. Okay, so we have more warm air is actually being drawn towards this low pressure, and more warm air rises up. And when more warm air rises up, okay, what is going to happen? And guys, as this warm moist air rises up, there's actually a creation of clouds there. Okay, so cumulonimbus clouds develop. Okay, now you start developing cumulonimbus clouds. Okay, because the warm moist air, again, as it cools down, it condenses, forms clouds. So now you attract more warm air or more air from surrounding areas, and now more air rises up. So if there's more volume of air rising up, the pressure actually drops. So now as you can see, the pressure is actually below 1,000 now. So that's why we're saying that the intensity of the storm increases, okay, because air continues to converge and rise. We also see a divergence, okay, that is happening in the upper atmosphere. Because there's a divergence occurring there, upper air divergence, it actually, these air masses actually, uh, they actually fall down, descend, and they warm up. Okay, so as they are dropping down or falling, they are warming up. This is what we call the adiabatic warming, and hence again joining moving towards this low pressure. So now, as you can see, you have this cell that you have created. Okay, this this circulation. Okay, side view circulation that you can see here. Okay, so now this ensures that this promotes the growth of the tropical cyclone. Okay, it's the first time we're seeing that there. The air pressure now is below 990 hectopascals. Again, with the values, guys, it may differ from textbook to textbook, resource to resource. The wind speed now increases. It's about 120 kilometers. From 60, it has almost doubled. So as you can see, more air um, is actually being attracted or pulled towards the low pressure at high speeds, 120 kilometers. So the tropical cyclone as a whole is starting to pick up strength, is starting to grow. Okay. Now the eye forms, but it is not very well developed. And we also see that we have cumulonimbus clouds that form the eye wall and they rotate around the eye. Okay, these cumulonimbus clouds. We see what we see from the top view is rotation like that. Okay, but still not at very high wind speeds. Okay, but we do see rotation there. Okay, right, and the eye is not yet fully developed. And then in the mature stage now, guys, first of all, we can see the eye is fully developed. Okay, the eye is well developed. Okay, we see that in this region there's definitely no rain, it's no clouds, it's warm. Okay, and so that is it's now distinct that okay, this is an eye, this region is an eye. In the development stage, it's not very clear. Okay, so of course the pressure drops to about 950. Okay, so it dropped from 990 to 950. So it continues to drop as more and more warm air rises up. Wind speed rises up to more than, so it's with an excess of 180 kilometers per hour. That is very high wind speeds. Okay, now this will differ again from tropical cyclone to tropical cyclone. The vortex is well developed. Okay, so if you look at this from the top view, you will see this. Okay, you will see a lot of circulation, a lot of spiraling. Okay, with of course the eye very being fully developed. Okay, but this system as a whole is it has air inside circulating while it is moving from east to west. Okay, while it is moving, the air is actually circulating inside like that, spiraling at wind speeds more than 180 kilometers per hour. So as you can see, guys, that's how you would identify a mature stage. Okay, and it is also grown in size, in diameter. It's up to 600 kilometers. I mean, it's not as big as a mid-latitude cyclone, but it is very aggressive and it is very destructive. Okay, due to these high wind speeds and downpouring rain, thunder, and lightning. Okay, so these two weather changes that we see here, these are the very much core of destruction or cause of destruction of tropical cyclones. Okay, so that is the mature stage. And lastly, the decaying stage. So with the decaying stage, guys, this occurs when a tropical cyclone actually enters colder oceans. Okay, remember, if it's going to enter colder oceans disrupt the circulation because now air in the system is rising up. Colder oceans will introduce colder air, which is actually sinking down. Okay, so this will disrupt the circulation and it will reduce the supply of moist air. Okay, remember, cold air, they do not retain a lot of moisture. Okay, and so now you no longer have that constant supply of moisture, and so now the system as a whole starts to disintegrate, starts to slow down, starts to weaken. Okay, so air cools down when entering the temperate latitude. And because this is cold air tends to sink. Okay, and as it sinks, it presses against the ground, putting high pressure on the ground. So, as we know, a tropical cyclone has a low pressure, okay, of about 950 hectopascals in the mature stage. But as it reaches colder oceans, the pressure starts to increase now. Okay, so you have increasing pressure, and so this weakens the strength or the intensity of the tropical cyclone. And this would further exacerbate that when it is moving inland, okay? Because when it moves into land, remember, land has no supply of moisture, okay? So the supply of moisture is cut off, and land has a lot of barriers. And so it actually slows down when it reaches land, okay? They like to ask the question, why does a tropical cyclone slow down or weaken in strength when it enters inland or moves inland? Well, there's no supply of moist air there, okay, because there's dry air. And also, there's a lot of barriers which increase the friction, slowing down the tropical cyclone as it is moving. Okay. Now, I hope I wasn't too fast, guys, because I can get carried up. Um, so I hope this will be helpful to you. Don't worry about activities, guys. I will make separate videos, um, and we'll do a lot of activities. Okay, if you have any activity that you would like for us to do in this channel, please send it via email, or you can send me the link via email, or even just type the paper or where I can find it, and then we will practice it. Okay, in the next videos. Okay, I'll see you in the next one.